Okay, so guys, today we are going to discuss our next topic that is called trunking. And I hope you guys have better understanding what is the difference between access port and trunk port. Clear? Access port means access port belongs to single VLAN and trunk port belongs to, or trunk port can carry multiple VLAN.
Multiple
Yes.
VLAN.
In previous class,
Yes.
we discussed one topology. This is the switch. Let's suppose there are PC1, PC2, PC3, PC4, PC5, PC6, PC7. I hope it's visible to all of you. Clear? All PCs are connected like this. All PCs are connected like this. Clear? Let's suppose this is IT department. This department use VLAN number 20. This is, let's suppose, HR department. This is using, let's suppose, VLAN number 20. And this is, let's suppose, sales department. It is using VLAN number 30. Clear, everyone? Now the thing is, we are using here switch. Okay. So this PC can easily communicate with PC2 and PC3 because both are in the same VLAN. There is no problem. Yes or no, everyone? Yes?
Yes.
Are tell me? Yes, na?
Yes.
PC5, PC6 and PC7 can easily communicate with each other. There is no problem. Yes or no? Yes?
Yes.
And there is one more PC, let's suppose PC number 8, and this is also belongs to same HR department, that is VLAN number 20. But the point is, let's suppose I want to make communication possible in different VLAN. Means IT department can reach out to HR and HR can reach out to the sales. HR can reach out to the sales. What are the things I need to perform here? Anyone?
I need a router.
Okay, so you are telling we need router. It means we need to perform the inter-VLAN routing. Yes or no? Everyone?
Yes.
Yes?
Yes.
For example, I'm not going to perform inter-VLAN routing. Is there any more solution without inter-VLAN routing? I'm not going to use router. I'm not going to use any L3 switch. Is there any more method? Method means I'm not going to use inter-VLAN routing. Is there any more method? See guys, what I will do, I'm telling you, just take one router and between this switch and router, use 3 link. How many link? 3 link. Are you getting my point? Yes or no? Yes, na? This link belongs to, let's suppose, VLAN number. Where is? This is VLAN number 10, na? 10, 20, and 30. Can I make communication possible now?
Yes.
Yes, we can.
We can? Yes or no?
Yes.
Yes. Yes, we can.
We can, because for every VLAN, we have a separate interface here.
Yes.
For every VLAN, we have a separate interface here. There is no problem. Yes or no, everyone? Yes.
Yes.
But in yesterday class, what we did, we just use how many link?
One single link.
And I configure this link as a trunk link. Yes or no? Yes, na?
Yes.
So basically, if we are using the trunk link, it means we are avoiding the wastage of interface here. Yes or no? Yes?
Yes.
If we do not use the trunk, it means how many interface we are using here? 3 different
One.
link or 3 different interface? Yes or no? Yes? But if we are using the trunk, only one interface we are using. It means by the help of trunk, we can avoid the wastage of interface. Clear? Everyone? Anyone? Any problem? Any doubt? Clear na? Yes or no?
Yes.
Yes.
Now, let's suppose now we have a topology like this. Switch 1, switch 2. Again, we have, let's suppose, PC1, PC2, and both are IT department, VLAN number 10. We have sales department, PC3, PC4, VLAN number 20. And let's suppose we have again IT department. Here, let's suppose VLAN, PC number 5, PC number 6. And both belongs to which VLAN, guys? VLAN number 10. Because IT department, here I configure which VLAN? 10, na? So here also VLAN number 10. Are you getting my point? Yes or no? Yes, na? Are you tell me?
Yes.
Okay. There is one HR department. Let's suppose there is PC1, PC2, and these are belongs to VLAN number. Let's suppose 30. Let's suppose 30. Are you clear? Understand? So topology is like this. Topology is like this. Clear? Now, here we have a router. Here we have a router. What we are doing? We are using how many link? 3 link.
Really.
Guys, 3 link. Between the switches, we are using 2 link. Between the switches, we are using how many link? 2 link. Can anyone tell me, is it correct or is there any problem? Try to understand the thing here. What I am trying to say, we have a IT department, and in IT department we have a 2 PC, PC1, PC2, and both PC belongs to VLAN number 10. Clear, everyone? Done?
Yes.
We have a, again IT department, PC5, PC6, both are part of VLAN number 10. Any doubt? No doubt. Between switch 1 and switch number 2, we have a how many link?
2 link.
1 link,
Dual link.
for number 10. Understand? And 1 link, let's suppose what we configure. Let's suppose VLAN number 20. Clear? Understand? Are you tell me?
Yes.
Understand na? Okay. Now the thing is, can I make communication possible from PC1 to PC5? Arey, PC number 1 will generate the packet. Packet will reach on switch. What switch will do? Switch will forward this packet through all the interface which is a part of VLAN number 10. Yes or no? Yes?
Yes.
Yes.
So switch will forward this packet through this interface. Yes or no? Yes?
Yes.
Packet will reach on switch number 2.
2.
2.
Switch number 2. Now, here what switch will do?
Forward
Would-
the packet
would
to
Forward.
PC6.
PC5.
PC5
PC5
directly,
yeah,
directly
PC5.
it can send yes or no. Because on
Yes.
switch number 2, you already configure na VLAN number 10 and VLAN number 30. Yes or no?
Okay.
And these interface is a part of VLAN number 10. So this switch do not forward your packet towards the router. Do you need inter-VLAN routing here? No, na?
No.
Switch number 2 directly forward your packet towards PC number 5 and PC number 6. Yes or no? Everyone, tell me.
Yes.
Clear now? Understand? Everyone. Now the thing is, let's suppose PC number 1, this PC wants to communicate with this PC. What will happen? Packet will reach on switch. What switch will do?
Two.
The switch receive this packet here, and this interface belongs to which VLAN? VLAN number 30. Yes or no? Yes?
Yes.
Yes.
This one VLAN number 10, this is 20, and this is VLAN number 30. So what switch number 2 will do? Switch number 2 do not forward this packet towards here, right? Yes or no? Yes, na?
Yes.
Yes.
Because there is only how many links here? 2 link. How many links here? 2 link. Are you getting my point? Yes or no?
Yes.
Between switch 1 and switch 2, how many links is there? Only 2 link is there. Why we are using only 2 link? Because on switch number 1, we are using only VLAN 10 and 20. We are not using VLAN number 30. Getting my point? So that's the reason we are using only how many links? 2 links here.
2 links.
So what switch will do here? Switch will forward this traffic towards through this link, right? Everyone, are you tell me?
Yes.
This link
Yes.
towards the router. Are you tell me? Towards the router.
Router.
No, everyone.
Yes.
Guys, yes, na? So now what
Yes, sir.
router will do? On router, you guys already running na encapsulation protocol .1q, right?
Yes.
You already running encapsulation protocol. So when this packet will reach, what router will do? Router will rewrite your packet and forward your packet through the interface, which is a part of VLAN number 10, because your
10.
destination belongs to VLAN number 10. So this router forward this packet through this link. Yes or no? Tell me.
Yes.
Yes,
sir.
packet will reach on switch number 2. Fine. So when switch number 2 receive this packet on this interface, it means this interface is a part of which VLAN? VLAN number 10.
10.
And switch number 2 will forward this packet through this interface, because this link is a part of VLAN number 10. Packet will reach on switch number 1, and switch number 1 will forward this packet through VLAN number 10. That is this one.
PC1.
Getting my point, everyone? Do you guys understand something?
Yes.
Tell me. Understand? Everyone.
Yes, sir.
Now the thing is, I told you right now 2 topology. In first topology, what we see between the switches and between the router, how many links we are using? 3 links we are using. Here, in this topology, between the switch and router, how many links we are using? 3 links we are using. Between the switches, how many links we are using? 2 links
2.
we are using. So it means definitely we are just wasting the link. Yes or no? Everyone, tell me. We are
Yes.
just wasting the link. Right now, everyone, because for every individual VLAN, we are using the separate link. Yes or no? Everyone, tell me. Let's suppose
Yes.
if you are working in a very small company or very small network, and if there are limited VLAN, so in this case, you can use the separate interface for separate VLAN. But let's suppose if in your company there are number of VLANs. So in this case, if you are using the number of interface, it means you are wasting the interface. Are you tell me yes or no? Yes, na everyone?
Yes, sir.
Yes.
So to avoid these type of thing, we have a concept of trunk. To avoid these type of thing, we have a concept of trunk port. So what trunk port will do? Trunk port can carry multiple
VLANs.
VLAN through a single link.
Thank you.
Are you getting my point? Yes, na everyone? I hope
Yes,
now
sir.
you guys have better understanding actually why we need the trunk.
Trunk.
Understand everyone?
Yes, sir.
Yes.
Now, so in this topology, if we use the trunk, what we will do? Only one link we will use, and we will configure this link as the
Trunk.
trunk link. Yes or no, everyone? Tell me.
Yes.
And if we configure this link as the trunk link, it means every VLAN can communicate with each other. There is no problem. Yes or no?
Yes.
Yes.
So basically, this is the use of trunk. Clear, everyone? Tell me. Understand?
Yes.
Yes.
In previous class, I told you one thing. Trunk port carry the, or you can say trunk port is also known as tagged port, and access port is known as untagged port. I told you in previous class. It means
Yes.
whenever your traffic will go through the trunk port, the VLAN ID will be tagged. Right now, and when the traffic will go through the access port, there is no tagging, because access port means single VLAN. But in case of trunk, your data, your packet will be tagged. Because if your data will be not tagged, then how your destination device will understand this frame belongs to which VLAN? Are you getting my point? Yes or no?
Yes.
Yes, na? So to understand or to make the things clear, so we have a concept of tagging. Understand, everyone? Tell me. Clear na?
Yes.
That is called tagging. And this tagging process is known as, guys, encapsulation. What is encapsulation? Now the thing is, actually, now there are two things will happen. First one is encapsulation and second one is decapsulation. Try to understand what I'm trying to say. For example, from here to here you are pinging. Packet will reach on switch number 2. Are you getting my point? Yes or no? This packet,
Yes.
which interface? This one. This interface is a part of VLAN number 30. Yes or no? What switch will do? Switch will forward this packet through all the interface which is a part of VLAN number 30 as well as the trunk port.
Trunk port.
Again, I'm telling this switch will forward this packet through all the interface which is a part of VLAN number 30 if this is the broadcast packet. I'm telling you about the broadcast, not unicast. So this switch will forward this packet through the trunk port also. So when this switch will forward this packet towards the trunk port, this switch will add the VLAN tag in your packet. Are you getting my point? Yes or no? Because when you configure the trunk, you configure the encapsulation protocol that is called .1q. Yes, na everyone? Tell
Yes.
me.
Yes.
So what this switch will do? This switch will add the VLAN tag with your packet. Fine. So that when the VLAN tag is adding with your packet, that is called encapsulation. And when this packet will reach on this switch, what switch will do? This switch will first of all open your packet, check the tag, and once this switch will find the tag, this switch will remove the tag first and forward the original packet towards here. It means this PC received the original packet, not tagged packet. Are you getting my point? Yes or no? It means
Yes.
on this interface, this switch will remove the tag, and after remove the tag, this switch will forward this packet towards PC number 1. So here what is happening? Decapsulation is happening. What is, guys? Decapsulation is happening. Here encapsulation or here decapsulation. Are you getting my point, everyone? Yes or no? Yes, na? So encapsulation and decapsulation is happening because of the what? Trunking protocol that is called .1. Are you clear, everyone? Yes or no? Yes, na?
Yes. Sir.
Yes.
There is one interview question. Question is, if any interviewer will ask you, just tell me one thing. If I configure here .1q and here I configure ISL, is it fine? Answer is no.
No.
You must need to configure the same encapsulation protocol both end, guys. Are you getting my point? Yes or no? Yes, na?
Yes.
This is the interview questions. No voice?
Can you repeat
Yes.
it one more time, please? Your question, please.
Question was, can I use encapsulation protocol .1q and here ISL? Answer is no.
No.
On a trunk port or on a trunk link, you must need to configure the same encapsulation protocol at the both end.
Both.
Getting my point? Then after, your destination switch will able to understand your encapsulated packet. Are you getting my point? Yes or no? Yes, na?
Yes.
Yes.
In previous class, I told you something about the VLAN tagging. Everyone. There are two different protocols for VLAN tagging. First one is ISL and
ISL.
second one is .1Q.
1Q.
.1Q is also known as 802.1Q, but generally we are telling .1Q. Are you clear, everyone?
Yes.
ISL is the, I told you, Cisco
Cisco
proprietary,
proprietary.
and this is the old one. Even nowadays, Cisco is not recommending this one. Nowadays, even in the real scenarios, you guys are always working .1Q. Are you getting my point? Yes or no? Yes.
Yes.
Who created .1Q? That is IEEE. Who created, guys?
IEEE.
Institute of Electrical and Electronics Engineer.
Okay.
So this is the organization. This organization created the .1Q, and this is the open standard. Understand, everyone? Clear na? So even in the real scenario, you guys will never use ISL. You guys will never use ISL.
ISL.
Okay. Now we are discussing the switching. Switching means at which layer? Layer number 2. At layer number 2, which type of header, guys, you guys will get? Ethernet header. Yes or no? Tell me. Right na?
Yes.
Or you can say Ethernet frame.
Frame.
So basically, na, Ethernet frames looks like this one. So here you guys will get Ethernet header, then you guys will get packet, and then you guys will get Ethernet trailer. Understand? So this is your Ethernet frame looks like this one, or you can say at layer number 2. Layer number 2 data is known as frame. I told you in case when I explain you the OSI model. Yes or no? Yes, na? At
Yes.
layer number 2, data is known as frame. So your frame looks like this one. First part is Ethernet header, then packet. This packet comes from layer number 3, right? And this is called Ethernet trailer. Are you getting my point? Yes or no? Yes, na?
Yes.
In Ethernet trailer, you guys will get one column that is called FCS, frame check sequence. Frame check sequence. What is the use of FCS? Who can tell me? Error detection. Error detection. I told you, na? Array CRC algorithm. Please remember.
Yes, yes.
So, device run the CRC algorithm
Yes.
and try to find one number, right? Na? And at
This
the
is-
destination end, that device also run the same algorithm and try to find out the number. If both number will match, then your destination device will accept that packet. Otherwise, no. Now, come on the Ethernet header. So, I already show you the Ethernet header. In Ethernet header, you guys, I hope you guys remember, I show you preamble, right? After preamble, you guys see SFD. Then you guys will see destination MAC. Then you guys will see source MAC. Then you guys will see tie field. So basically, this is called Ethernet header. Are you guys remember? Yes or no? No one? Oh my God. Are you tell me yes or no? No one? Ethernet header.
Sir, we haven't discussed the internet header in details.
Yes, I already explained you. Where you guys? See, I am opening anyone. Let's suppose this one. I hope this is visible to all of you. Is it visible?
Yes.
Okay. Ina,
IEEE.
what is this? Preamble, told you.
Preamble.
SFT, told you. Destination MAC, told you. Source MAC, told you. And then you guys will get the type field. This is the length. Length means total size. Total size. Understand, everyone? So basically, this is called Ethernet header. This is called Ethernet header. Are you getting my point? Yes or no?
Frame check sequence.
Yes.
Frame check sequence. Yes.
So basically, the frame is divided into two categories. First one is called Ethernet header, and second one is called Ethernet trailer. So in trailer, you guys will get the FCS field, and in header, you guys will get these type of thing. Clear, everyone?
Okay. Yes.
Understand? Okay. Now, this is called Ethernet header. Okay. Now, when you are using .1q and .1q, definitely you guys will use at layer number 2. Yes or no? Yes. So
Yes.
Yes.
this is before .1q. Yes or no? Your header looks like this before .1q. Yes or no? Yes, na? Are tell me. Right now, I do not configure any .1q. So once you configure the .1q, it means after .1q, your header looks like how? Preamble. After that, SFD, then destination MAC,
Destination.
and source MAC, and
Oh.
after that you guys will get here .1q tab, and after that you guys will get the tab or length.
Right or length.
So this is the format after the .1q.
Oh.
Are you getting my point? When you use the encapsulation protocol .1q, your header looks like this one. Yesterday class I saw you guys. Where are you guys? In yesterday class I saw you already, right? Na?
Yes.
Yes.
So this is the before encapsulation and this is the after encapsulation.
Encapsulation.
Clear, everyone? Anyone
Yes.
who do not understand? Tell me. Understand, na? So generally the .1q tag you guys will see after the source, and you can say between the source and type field. Understand, everyone? And one more thing, if you guys remember, in yesterday class I told you what is the size of .1q, guys? 4
bytes.
But if you use the ISL, how much? 30 byte. So that's the reason we are not using the ISL, because ISL is using the heavy data with your packet. Getting my point? So that's the reason we are not using the ISL. We are using the .1q. Getting my point? Yes, na, everyone?
Yes.
So .1q, if you are using the .1q encapsulation method, it means .1q encapsulation method add the 4 byte extra information with your original packet. With your original packet, how much extra data, guys? Only 4 byte. But if you use the ISL, it add how much? 30 byte extra data.
Bytes.
So that's the reason we will prefer .1q. Are you getting my point? Yes, na, everyone?
Yes.
Okay. Now, .1q, this .1q also divided into 2 parts. Or you can say in .1q, you guys will get the 2 field. First one is, guys, TPID. And second one is you guys will get TCI. TPID means tag protocol identifier. Tag protocol identifier. And TCI means tag control information. Are you tell me yes or no? Understand, na? Clear? Guys, understand? Yes or no?
Yes.
So .1q is also divided into, or you can say in .1q, there are how many parts? 2 parts. TPID or TCI. I'm just telling you something about the TPID or TCI. But this is not the, again, I'm telling this is not the part of ccna, but I'm telling, maybe you guys will understand something. See, actually, this is the .1q. Okay. What is the size, guys? 4 byte. 4 byte means how much bit? 8 into 4, 32 bit. Yes, na? Okay. So in 32 bit, this is divided into like this. 16 bit is known as TPID. 16 bit is known as TPID. Okay. Now that is TCI, tag control identifier. Now tag control identifier is again divided into 3 categories. 3 category. What are the 3 categories here? 1, 2, 3. Guys, 16 bit is this one. It means total size of TCI is also 16. Then 16 plus 16, how much? 32. So first 3 bit is known as PCP. Then again 1 bit is known as DEI, and the last one is called 12 bit is known as VID. VID. Are you getting my point, everyone? Understand? This is called
Yes.
TCI part. This is
TCI.
called TCI part. What is
TCI.
TP? What is TPID? Anyone? I told you in yesterday class. TPID tells us in TPID always you guys will get the value 0x8100. This value always you guys will get. Basically, this value indicate that your frame
Is tagged.
is .1q tagged. What? .1q tag.
Tagged.
Are you getting my point? Understand now? Everyone.
Yes.
And this is the
Yes, sir.
hexadecimal value. Clear? Everyone. Are you tell me? Now, next one is guys, tag control identifier, TCI. The first 3 bit is called PCP. PCP means, you can check on Google guys. Actually, I don't know exact full form, but I think priority code point. Okay, but you can check the exact one. So basically, this 3 bit is used for quality of services. What? Quality of
Service.
Understand?
Could be voice VLAN or something like that. Yeah.
Like this to prioritize the data. Clear, everyone? Understand? The next one is called
Yes.
DEI.
DEI.
DEI is something stands for drop eligible indicator. I think you guys can check, confirm. Drop eligible indicator. Okay. So basically, what is the size? 1 bit. What is 1 bit? Understand? Basically, this field is used to indicate the dropped packet in your network. If any packet will drop in your network, this DIE field indicate that. And the next one is called guys VID. VID means VLAN ID. Arey VID means VLAN.
VLAN ID.
Okay na? And I hope you guys all already understand VLAN.
Sir,
Yes.
I have a book of discovery for ccna. So DFI, I have here CFI, canonical format identifier.
Canonical format. See, basically, the thing is,
Identify.
yes, CFI is, you can say this is the algorithm. This is the algorithm. In multiple books, you guys will get the different thing. Okay, na? But try to understand. Actually, I'm telling you, understand like this. This is the simplest form by which you guys can understand. See, basically, if you configure, when you go the PCP is again divided into 3 parts. So that is more complex. Okay. So make it easy. Understand like this. Clear na? Are you tell me?
Yes.
Understand?
Yes, sir.
So when you divide the PCP, PCP is again divided into 3 categories. You are telling CFI. So CFI is also part of this one. So that's the reason I'm not going to make it more complex. I'm just telling you the overview so you guys can understand in a single go. Clear, everyone?
Yes, sir.
See, next one is guys VLAN ID. VLAN ID, what is the size? 12
Bit.
So 12 bit, 1 bit and 3 bit. How much? 16 bit na? Okay.
Yes.
And VLAN ID tells you about your frame belongs to which VLAN. This part is telling your actual frame belongs to which VLAN. Are clear, everyone? Yes or no?
Yes.
Clear na?
Yes.
Are tell me.
Yes.
So basically, what is the bit? 12 bit. So if you write the 2 the power 12, I think you guys will get value around 4096 when you get the value, right? And that is the total number of VLAN. What is the range of VLAN? 0 to 4095. This is the range, na? Everyone. Even 0 and 4095 are reserved. Okay, everyone. I hope you guys understand something. Tell me.
Yes, sir.
Yes.
Okay. So this is the range of VLAN 0 to 4095. Are you understand na? So 1
Yes.
to 1005. This is called a normal range of VLAN, and generally 90% case you are using this one. And 1006 to 4094. This is called extended range of VLAN. Understand? Even some older switches do not support the extended range of VLAN. Are you clear? Yes or no?
Yes.
Okay.
Okay. Now, one more concept. Switch one. Switch. We are using router, and this is the trunk port, right? This is the trunk. I hope you guys now understand. This is PC1, PC2, PC3, PC4, PC5, PC6, and PC7. These are part of VLAN number 10. Understand? This is part of, let's suppose, VLAN number 30, and this is part, let's suppose, VLAN number 20, and this is again part of VLAN number 10. Are you tell me? Clear na?
Yes.
Yes.
And this is, guys, this is called trunk link.
Port.
This is the trunk port, or you can say trunk link. Clear? Now, for example, this PC wants to communicate with this one. Packet will reach on. What PC number, switch number 2 will do? Switch number forward this packet. This switch number, add the VLAN tag, VLAN number 10, and forward this packet to what? Switch number 1. Switch number 2, open it and check what is the VLAN tag here. VLAN number 10. This switch remove the VLAN number 10 and forward this packet towards PC number 1. Are you clear now, everyone? Yes or no?
Yes.
Yes.
Anyone
Yes.
who do not understand? Okay. Now, the next thing is native VLAN. What is native VLAN? Anyone? Any idea about the native VLAN? Anyone?
Native VLAN is untagged. This is
Native VLAN is untagged. Okay.
Yeah.
See, I written, guys, some point here about the native VLAN. Please read it. The native VLAN is a special VLAN on a switch that handle untagged traffic on the trunk link. Untagged traffic on the trunk link. By default, VLAN 1 is called the native VLAN. The native VLAN is a unique because when a frame from the native VLAN sent across the trunk link, it is sent without the VLAN tag. It means this is the untagged. This untagged frame is then recognized by the receiving switch as belonging to the native VLAN. Understand? Now,
Yes.
I written one more point here. When a switch receive a untagged packet on the trunk port, it need to decide how to handle that packet because trunk port are usually used to carry the traffic with multiple VLAN, right na? Trunk
Yes.
port
Yes.
carry the multiple VLAN and each identified by the VLAN tag, right? For every VLAN there is a VLAN tag. But let's suppose if a switch receive any packet without the tag, then switch will assume that packet belongs to native VLAN. Are you getting my point? Yes or no? Understand na? Native
Yes.
VLAN means native VLAN, or you can say native VLAN is a special type of VLAN, and .1q is the encapsulation protocol that support the native VLAN. It means for the native VLAN, .1q do not perform any types of tagging. Again, I am telling, please remember like this. .1q, if any VLAN belongs to the native VLAN, .1q do not perform tagging. Getting my point, everyone? But if you use the ISL perform tagging. So
Again.
that's the reason this is the second difference. That's the reason we are not using ISL. ISL even perform the tagging for the native VLAN. Are you getting my point? Yes or no? Yes, na? But
Yes.
.1q do not perform tagging. Now you guys
Sir,
will ask, sir, just a minute. Now you guys will ask, sir, what is the problem here? If ISL is perform tagging, then it's fine. Switch will easily understand. Then what is the problem? But try to understand between the switches, guys, or on the trunk link, there are multiple packets. That is called management packet, guys. Switches are exchange. Switches exchange. For example, keep alive messages, CDP messages, LLDP messages, VTP messages, DTP messages. These are called management VLAN or discovery and basically used for the discovery. Getting my point? These are the by default packet. After some interval of time, switches are exchanging these messages. Getting my point? So if switches are, or if your encapsulation protocol is performing tagging for these packets also, then assume how much load on this link. Quite high. Yes or no? Everyone. Are you tell me?
Yes.
Understand, na? So that's the reason we do not want. So for the network management packet like CDP, VDP, for these packet, we do not want tagging. Because when this packet will reach on switch number 2 always process. Switch number 2 do not check the VLAN. There is no need. So then why we are tagging the VLAN? Unnecessary utilization of bandwidth of the link. Are you getting my point? Yes or no? Everyone.
Yeah.
Yes, na? So that's the reason .1q is has an advanced feature. So .1q do not perform tagging for management traffic. Getting my point, everyone? I hope you guys understand something. Yes, Nabil. Now ask.
I want to ask, how does the switch recognize that this is the native VLAN properly?
Switch will only understand this is the native VLAN when switch will receive the packet on the trunk port without tag. Without tag, then switch will understand this is the part of native VLAN. And on a switch, you can configure only single native VLAN. Yes or no? Single native VLAN, then there is no confusion.
Could we change the native VLAN on other native VLAN? Or
Sorry?
we could also change native VLAN.
Yes.
For
By
example.
default, it is VLAN number 1. But yes, definitely we can change the native VLAN. And native VLAN must be match, guys. Let's suppose if you are using here VLAN number 10 as the native VLAN, here you must need to configure VLAN number 10 as the native VLAN. Otherwise, you guys will get the error native VLAN mismatch.
Mhm.
Okay.
Clear? Everyone? Understand?
Yes.
Okay. Anyone who do not understand? Clear na? Everyone? Tell me.
Yes, sir.
Okay. See, na, actually, I written some more. These things I told you. Apart from this, it is also possible any user device is connected to the native VLAN. Yes, there is one more scenario. For example, guys, see here. I told you about the management traffic, right? Everyone, like CDP, VTP, these are the untagged. Tell me yes or no. Yes, na?
Yes.
For example, on this switch, I configure VLAN number 10 as the native VLAN. But see, na, these two PCs already part of which VLAN? VLAN number 10. Yes or no? Everyone, tell me. Yes?
Yes.
So when PC number 1 will send the packet will reach on switch. Switch check. I am receiving this packet on this interface and this interface is a part of VLAN number 10. Are you tell me yes or no? Yes.
Yes.
And switch also check. What is the native VLAN? Native VLAN is also VLAN.
Yeah.
So this switch will forward this packet towards switch number 2 without tagging. Without tagging. Because in your native VLAN, your two users are sitting in your native VLAN. So all the packet from these two PC is untagged. Are you getting my point? So when this packet will reach on switch number 2 will check the packet without untag. It means this is the part of which VLAN? Native VLAN. Switch number 2 forward this packet through these two interface, because these two interface is also a part of VLAN number 10, that is native. Are you clear everyone? Yes or no?
Yes, sir.
Everyone, do you guys understand?
Yes, sir.
Okay. I mentioned here guys one scenario. You have a two switch A and switch B connected to the trunk link on this interface. The native VLAN is, for example, 99. What is 99? Clear? Let me draw the topology. Switch number 1, switch number 2, and both are connected with the, and what is the native VLAN guys? 99.
99.
Are you clear? Yes or no? Okay. VLAN 10 and 20 both are being carried across the trunk link. For example, here VLAN number 10, VLAN number 20, 10 and 20. Clear? Device
Yes.
D1 is connected to the switch A, belongs to the VLAN 99. Device D2 is connected to the switch B. Let's suppose this is the device number 1 and this is the device number 2, and both are connected to the VLAN number 99. It means both are belongs to native VLAN. Yes or no? Everyone, are you tell me?
Mhm.
Yes, na? So when
Yes.
this
Yes.
device will send the packet will reach here. Switch will check I am receiving this packet on this interface, and this interface is the part of VLAN number 99, and this 99 is also native. So this switch will forward this packet through this link without tagging. This packet will reach on switch number 2. What switch number 2 will do? Switch number 2 will check I am receiving this packet on the trunk link without tag. It means this packet must belongs to native VLAN. And what is the native VLAN on switch number 2? 99. So switch number 2 forward this packet towards here.
Mhm.
Clear? Everyone. Understand? Tell me.
Yes.
Okay. And one more thing, I written one command here. I do not try it, but if you want, you guys can try it. I told you na .1q do not perform tagging for the native VLAN. Yes or no?
Yes.
Right? If you want tagging, this is the command. You guys can try in the packet tracer. Maybe it will work. This is the command. Once you guys run this command, your switch start tagging the native VLAN also. Clear? Everyone? Can you tell me?
Yes.
Yes.
Okay. I hope you guys understand the native VLAN. Anyone who do not understand, if you guys understand, can I ask you some question then?
Yes.
Are you guys ready?
At least, sir.
Yes.
Yes.
Okay. Ten means VLAN number 10. Okay. 30 means VLAN number 30. 20 means VLAN number 20. And again, this is VLAN number 10. Okay. This is the trunk and this is the trunk. Clear? Any doubt? Anyone?
No.
No? Okay. Guys, on this interface, I configure native VLAN 10 and here I configure native VLAN 10. Clear everyone? Tell me yes or no. Yes?
Yes.
Yes.
Now, this PC send the packet will reach on switch number 2. Now, Nabil, tell me what will happen now, how this switch number 2 will handle this traffic.
The switch number 2 will forward the frame without tagging.
Without tagging. Through which interface?
Exit interface.
Exit means here na.
Yeah, right.
So this switch forward this packet towards here. What switch number 1 will do? Switch number 2 receive this packet here. Switch number 1, what switch number 1 will do?
They will forward
Forward to
the receiving packet.
Switch number 1 open this packet and switch number 1 will find for this packet there is no tag. So it means this packet must belongs to native VLAN, that is VLAN number
Native
10.
VLAN.
Switch number 1 forward this packet towards here. Anyone? Any confusion?
No.
Anyone?
No.
Okay, very good. Now, Rahul, are you there?
Yes, sir.
Okay. Now, question is little bit change. Now the question
sir.
is, here I configure native VLAN 10 and here I configure native VLAN 30. Clear? This PC
Yes, sir.
send the packet reach on switch number 2. Now tell what will happen.
Sir, it will do tagging. Switch number 2 will do tagging. And
Switch number 2, so when this packet will reach here, switch number 2 will do the tagging.
tagging.
Okay,
Yeah.
it means you are telling VLAN number 10 tag. Okay, now
Yeah.
switch number 2 forward this packet to switch number 1. Yes? What switch
Yes,
number
sir.
1 will do?
Sir, it will check the tagging.
Oh, switch number 1 will check or open this packet, check the tag, then it will find VLAN number 10. So switch number 1 will forward this packet towards here. Yes?
Yes, sir. VLAN number 10.
VLAN number 10. Okay, good. Now, just wait a minute, guys. Saeed, are you there?
Yes, sir.
Okay. Can you answer something?
I think there will be error if both switch native VLAN is different.
Leave the error. Leave the error. I configure like this and I'm ignoring the error. So Rahul told me this type of scenario will happen. Is it correct or you have a different answer?
I
I'm
think
just
packet
telling
will
you,
be
ignore the
packet will be dropped.
pack. I am just asking the packet flow. Packet flow will be same or it will be different?
Packet will be dropped at S2 exit interface.
Packet will be dropped.
Yes.
Where?
S2.
So you are telling at switch number
The
2
present.
packet will be dropped, right?
Yes.
Okay, so if switch number 2 a packet will be dropped, then there will be no packet flow. Okay, fine. Now, next is Ibn. Are you there?
Yes, sir.
Do you
So,
have any other opinion?
yeah, I think when the packet reaches on S2, it will check the VLAN tagging. It's native VLAN it's 10, so it will forward to S1, and there when the switch
First thing,
check.
just tell me when this packet will reach on switch number 2. Switch number 2, drop it or process it.
Sorry, your voice are breaking.
I am telling when packet will reach on switch number 2, so switch number 2 will process it or drop it. This is the first question.
Sorry, sir, your voice is breaking. Is it only for me?
Guys, my voice is dropping.
I can hear.
Yeah. Now I can hear.
Probably.
Now I can hear.
So, Ibn, my question is when this packet will reach on switch number 2, my first question, switch number 2 will drop this packet or process this packet?
Yeah, I think it will process the process to
Process this
S1.
packet. Okay.
Yes.
So now, switch number 2 will perform the tagging. Yes or no?
No, it will not tag, but as this
will not
S2 will
tag.
see. Yeah, in S2 is it? It's
See, actually,
VLAN.
native VLAN is already configured here. It
Yeah,
will not tag.
it's already native VLAN, right? So it will not tag.
Okay. So it will
Yeah.
not tag. Without tag, it will reach at switch number 1. Okay.
Yes. So
Then
in S1 we have configured it VLAN as 30. So I think the packet will drop in S1.
okay. So you are telling at switch number 1, drop this packet because of native VLAN mismatch, right?
Yeah. Yes, correct.
Okay. Next one, Lakshman. No. Sankar. Elizabo. One. Deepak.
Yes, sir.
Yes. Do you have something? Or you already told?
Mm,
Yes, Nabil, I will come to you. Wait. Okay. Yes, Nabil, tell me something.
So from VLAN 10 to switch number S2, they will forward the packets or the frame without tagging until
Okay.
switch number S1. They will check the VLAN ID, and we will consider this is a native VLAN. But native VLAN 30 is here defined as S1, so it will forward the frame to VLAN 30.
So you are telling it will forward the frame towards the VLAN number 30.
30 because it is here intact and intact frame with forwarded only
So
to a
just tell me,
native
Nabil,
VLAN.
one thing. Do you agree with Ibn? Yes or no? Or partial?
No.
According
Switch
to
no.
the Ibn, packet will drop at switch number 1. Switch number 1 do not forward towards either VLAN 10 or 30. But I think you are telling everything is fine. Packet will drop, but at I think at here at this PC number 2, right?
Right, yeah.
Okay. Now see the answer. What you guys are thinking? Whose answer is correct? Okay. Ibn, your answer is correct. This answer is correct, guys. Switch number 1. Nabil, you also reached almost correct, but switch number 1 do not forward towards here. Because when this here, when this device send the packet will reach here. Here, what is the native VLAN, guys? VLAN number 10. Yes.
Number 10.
And switch number 2 receive the same packet here. And this interface is also a part of VLAN number 10. Fine. And it means VLAN number 10 is the native VLAN. So switch number 2 do not perform tagging. So it means switch number 2 forward this packet without tagging. No tagging, right? Packet will reach here. So when switch number 1 receive this packet, switch number 1 first of all check tag. So is there any tag? No tag. In this packet, is there any tag, guys? No tag. Then switch number 1 will think, if there is no tag, definitely this packet belongs to native VLAN. Yes or no? Everyone? Yes.
Yeah,
Now
sure.
switch number 1 will check, what is the native VLAN on me? Native VLAN is 30. Understand, everyone? But are you
Yes.
tell me yes or no? Yes, na? On the basis of native VLAN, switch do not forward the packet. After that, switch will check. After that, switch will open this packet and check the destination MAC and try to find destination MAC in which table? MAC address table. And in MAC address table, what is the entry? VLAN number 10, na? Yes or no? Are destination MAC, what is the entry?
VLAN number
10.
10.
Are when switch number 1 have MAC address, na? For example, MAC address is 0A and 0B. Fine. Interface is 0 by 1 and interface is 0 by 2. What is the entry? On 0 by 1, MAC address is 0A and this is the part of VLAN number 10. 0 by 2, what is the MAC address? 0B and this is the part of VLAN number 30. Yes or no? Yes?
Yes.
So when switch will check no tag, then check the native VLAN, then find the native VLAN is 30 configured on me. After that, switch will check the MAC address table. And in this packet, what is the, let's suppose the MAC address is 0D. What is the source MAC address, guys? 0D?
0D.
Tell me. And destination MAC address is 0A.
0.
So switch will find what is the 0A. 0A is this one. And 0A is part of which VLAN?
VLAN.
10.
10.
10. But on me, what is the native VLAN? 30.
30.
Getting my point. So that's the reason switch number 1 even drop this packet. Nabil, understand?
Yeah, sure. Thank you.
So guys, this is the interview type question. I hope you guys enjoy.
Yes, sir.
Yes.
Shubham,
Yes.
I have a question related to MTU size.
MTU size. Okay.
Yeah, MTU. Can you talk about an MTU size because
At the end of
the
the
size
class,
of
we will
MTU.
discuss. At the end of the
Okay,
class, we will discuss this. Okay, because this is the complete different thing. Clear?
okay. Thank you.
Okay. Now the thing is, so this is the topology we have. For example, in this topology, what we are doing, we configure the IP address here. Okay. So we are going to configure, guys, VLAN number 10, VLAN number 20, and VLAN number 30. Clear? Again, VLAN number 10, VLAN number 20. You guys created this topology or not in your packet tracer? No? I am asking to you.
Personally, I haven't yet.
I have created yesterday topology.
So yes, guys, please create the topology. It will help you. If you guys are not able to create, I will share this file with you. You guys can just open this file in your packet tracer. It will open. If you guys want. Otherwise, no problem. And guys, this will be our trunk link, right? Will be our trunk link. You know, na everyone?
Yes.
Okay. So first of all, let me check the IP address is configured or not. Here we configure 10.1. This is fine. Clear? Here 10.2, fine. 10.3, fine. 10.4, fine. 10.5, 10.6. These are the laptop users. Here we do not have IP address. So what we will do, we will configure, let's suppose, what is the configure last one, guys? 10.6, I think. Tell me.
Yeah.
10.6.
6.
So here configuring 10.0.0.7.
7. 7, 8.
Okay, IP address we configure. Now, on this switch, I think previously we already configured the VLAN also. Let me check. This is the switch number 1. What is the command? Show VLAN, guys. Brief.
Brief.
So VLAN number 10, 20 and 30 is configured 0 by 2 and 3. It means 2 and 3 is the part of VLAN number 10. Then guys 4 and 5. Both are part of
4 and
VLAN number 20. That is the
20.
IT department. And these 0, 6 and 7 is the part of
Finance team 30.
finance
VLAN
and 30.
30.
On switch number 1, we did. Now come on switch number 2. It is visible, na everyone?
Yes.
Show VLAN brief. Is there any VLAN? No. So what we need to do, first of all, need to create the VLAN. VLAN number 10. What is the name, guys? VLAN number 10. What is the name? I think IT, na?
IT.
IT.
Here I configure IT.
Yes.
Okay. IT, exit, then
VLAN
VLAN number
20.
what is the name?
Sales.
So,
Sales. Confirm, na?
Yes.
Sales. Okay. Then VLAN number 30 and name is
Finance.
finance. Exit. Now we need to, what we need to do, guys? Interface, range, fast Ethernet. What is 0 by 2 and 3, right na everyone?
yes.
They tell me
0 _3.
2, 3.
Yeah.
What is first of all? Switch
Switch
port,
port. Mode access.
Mode access.
access. Switch
Switch
port,
port access.
VLAN
VLAN
10.
10.
Interface, range, fast Ethernet. Then
4,
4 or
5.
5. Right na?
Yeah.
Tell me.
Yeah.
Yes.
So 2, 3, 4, 5, 6, 7. Yes. Sorry. 0, 4, 5. Switch port, mode, access,
Access.
port,
Switch port access VLAN 20.
interface, range, fast Ethernet 0 by 6 to 7.
7.
Switch port, mode,
Mode
access,
access.
switch port, access, VLAN 30.
30.
That's all. Clear, everyone? Do show VLAN.
VLAN brief.
So by this command, we can check VLAN 10, 20, 30 is configured, and these are the interface, right? And I told you, if you want to check any particular VLAN in a detail, what is the command? So
So
VLAN
VLAN
ID, let's suppose
ID.
10. So by this way, you can check. Now, what we need to do, we need to configure this link 0 by 1 as a trunk link. Yes or no? Right, na?
Yes.
Then after, all the VLAN can communicate with each other.
Communicate with each other.
Understand? So what is the command to check trunk is configured or not? So
VLAN.
interface trunk. So interface trunk. So do you get any result there? No.
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 It means no trunk port is configured.
Configured.
They understand? Yes or no?
Yes.
na? Okay. Now, everyone please focus how we configured. Interface, fast Ethernet. What is the interface, guys? 0 by 1.
0 by 1.
Yes.
Okay. Switch port,
Mode
mode,
trunk.
switch port,
Mode
mode,
trunk.
then trunk.
Trunk.
I can write this command, right? Everyone. Yes,
Yes.
or no?
Yes.
But this
Yes.
is not recommended. This is not recommended. Recommended is, first of all, you have to configure the encapsulation protocol. What?
Oh, yes.
Encapsulation protocol. There are two, even in GNS, when you try, you guys will get the error when you write this command. So interface, switch port mode trunk. When you write switch port mode trunk command, you guys will get the error.
Yeah.
Error means you guys are getting, first of all, you have to configure the encapsulation protocol. Are you getting my point? Yes or no? Yes, na?
Yes. Yes.
Yes.
But in packet tracer, you guys can write directly. And packet tracer choose the .1q by default. And even in the modern switches, you guys will get the .1q. But what is the best practice? You have to configure the encapsulation protocol first. Are you clear? What is the
Yes.
command? I don't think packet tracer will support, but I am writing the command. This is the command. Switch port trunk
Trunk
encapsulation.
encapsulation.
It is not
.1q.
working here, guys. Encapsulation. Okay. And then after you have to write here .1q. Are you getting my point? Understand? In packet tracer, it is not working. But yes, in GNS, you guys can try. This is the command. Clear? Everyone?
Yes.
Are you tell me? So first of all, what you have to do? You have to configure switch port, trunk, and then encapsulation, and then protocol. That is called .1q. Are you clear now, everyone? Yes or no? Are you tell me?
Yes, sir.
Now here, what is the command? Directly, what is the command I can write, guys? Switch port, mode, trunk. I write switch port, mode, trunk. Are you clear, everyone? Yes or no?
Yes.
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 Okay. Same command I have to run on which one? Switch number 1. Interface, fast Ethernet, 0 by 1, switch port, mode, trunk. Done? Everyone, tell me.
Yes.
Yes.
Port mode, trunk. So by default, what encapsulation protocol enabled, guys? Tell me. .1q.
802.1
Do so. What is the command to check the trunk interface?
Pro interface trunk.
Trunk. See here. What is the port? Fast Ethernet 0 by
1.
1. Fast Ethernet 0 by 1. It
1.
means this interface, right?
Yes.
Tell me. This interface I configure, na? Mode is
Yes.
on. It means it is configured. What is the encapsulation?
8.2.
So by
802.1.
default, it choose .1q. Are you getting my point? By default, it choose
Yes.
.1q. What is the status? Trunking. And what is
Trunking.
the native VLAN? By default, I told you, na, native VLAN is 1.
1.
Fine. And here, all the VLAN is allowed.
Allowed.
All the VLAN is allowed. But I told you in yesterday class, due to security reason, we are not doing like this. Yes or no?
Yes. Yes.
Yes, na, everyone. And these are the VLAN here allowed in active management domain. It means, see na, here in your topology, you configured VLAN number 10, you configure 20 and 30 VLAN 1. It means these are the active VLAN, right? In your topology. Yes or no?
Yes.
That's the reason these VLANs
1,
are
10, 20, 30.
clear, everyone. I hope you guys understand. Are tell me.
Understood.
Yes.
Now the thing
Yes.
is, native VLAN. Acha, before native VLAN, first of all, let's tell me one thing. By default, how many VLANs are allowed? All the VLANs are allowed. Yes or no?
Yes.
Yes.
Yes, na. But can we modify it? Yes, we can modify it. For example, what is the interface on which you configure the trunk? Interface fast Ethernet 0 by 1.
1.
One.
This is the interface na, where you configure the trunk. Okay.
Yes.
Yes.
Switch port,
Trunk.
trunk. I press the question mark. See na, allowed. You are getting na? Allowed.
Yes.
After allowed, I press the question mark. What is this?
VLAN
I am
number.
writing the VLAN. So here, after VLAN, I write the question mark. What are the things you are getting? You are
Word
getting
or add.
all except none.
Except one.
Getting my point? So these are
Yes.
the options you guys are getting. And for these options, there are different meaning. These options, different meaning. Are you getting my point? Yes or no?
Yes.
Yes.
For example, I write here switch port trunk allowed VLAN. Are you getting my point? I write here VLAN number 10 and VLAN number, let's suppose 20. VLAN number 10 and VLAN number 20, comma and 20 and exit. Now check do so interface trunk. See now, what is the VLAN allowed here?
10, 20
10
only.
and 20.
10 and 20.
20.
So it means if you try to ping to VLAN number 30, is it allowed?
No,
No.
it will not
It is
work.
not allowed. They understand, na? Yes or no?
Yes.
Yes, sir.
On switch number 1, it is not allowed. For example, I here, and I am writing here, let's suppose, ping 10.0.0.5. 10.0.0.5. What will happen?
It will drop the packet.
Why you are not able to communicate? Any reason?
Because it's not allowed to be forwarded.
Okay, very good. Now, come here. It's fine. On which PC? I think here I write na command. Yes or no? Here na? Okay,
Laptop
I'm writing again. See, it generates the packet. Yes or no? Packet reach on
Yes.
this
Switch.
switch. What is this? This is the ARP packet. It means this is the broadcast
ARP.
packet. Yes or no? Yes.
Yes.
Packet reach here. I told you all the interface,
Interference.
which is the part of VLAN number 30 as well as the trunk.
30.
Yes or no? Yes.
Yes.
So this packet will reach here as well as this switch forward this packet here. Packet will reach here. Now see na, inbound. It means this packet receive. Packet receive. Now see here na. What is this? In TCI field, you are getting na value. It means this is 30. It means this is VLAN number 30 tag is there. Yes or no?
Yes.
Yes na. But the question is, why switch number 1
1.
allowed it and why this switch is not allowed it? Why this switch forward this packet here and why this switch drop here? Because here you do not. Here everything is allowed.
Modify.
Here I do not modify anything. Here everything is allowed. But here you block
Allow
the
them
VLAN number 30. You do not allow VLAN number 30. So that's the reason your packet is dropping here.
drop.
Getting my point, everyone. I hope you guys understand. Clear?
Yes.
What is the solution?
Yes, sir.
Solution is you have to allow the
Allow
VLAN
the
number
VLAN 30.
30.
also.
Interface.
Fast Ethernet 0/1.
Interface fast Ethernet 0/1.
1.
What is the command? Switch port
Switch port. Trunk.
allowed
Allowed.
VLAN.
VLAN.
I'm allowing
10,
VLAN
20,
number 30.
30.
What I allowed? VLAN number 30.
30.
Now come here. Come here.
Dismiss.
Now ping. Sorry.
This means 30 only, I think.
10 and 20 we already allowed, na?
So
10
it,
and 20 we already allowed earlier.
yeah,
Hey, yeah, right, na? Yes or no?
existing one.
See na? Arre, see na? So interface trunk.
Trunk. Only 30 is allowed.
Okay, sorry, only 30 is allowed. Where I think on which switch we allowed?
Actually, we have
Yeah,
modified,
it's-
so that's why.
Okay, we already modified it. Okay, no problem. Interface fast Ethernet 0/1. Switch port trunk
Trunk.
allowed
Allowed.
VLAN
VLAN.
10
10, 20,
20,
30.
30.
Now
So
it will
interface
work.
trunk. See, now all
Trunk.
the VLAN is allowed. Okay. Now try to
Yeah.
ping here. You are getting reply?
Yes.
Tell me. Getting reply, na?
Yes. Yes.
I hope you guys understand. So in real scenarios also you guys will face these type of problem.
Issue.
Okay. So by this way you have to check it. Is it allowed? Let's suppose any client launch is there. Or let's suppose any new project is came. So definitely for new project, definitely you guys will create the new VLAN. Yes or no? Yes. So when you create the new VLAN, you guys first of all create the new VLAN on the access switch. Yes or no? Through the access switch, all the end users are connected. So, and through this access switch, one uplink, or you can say one fiber link, is going to the DR router or DR switch. Are they understand? Yes or no? And this is the trunk, and this is also trunk. Understand? Yes or no? Let's suppose that you create here 210 VLAN. VLAN number 210. Fine. So what you have to do? You have to allow na here 210. Yes or no?
Yes.
Tell me. Yes, na? So let's suppose as a network engineer, you allowed here, but here you do not allow. Definitely these users are not able to communicate with the internet. Yes or no? Yes. So as a network admin, you have to allow here as well as here. It means at access level as well as at the distribution layer. At both layer, you have to allow it. Are you getting my point? Yes or no? Yes, na?
Yeah.
And not only this, in multiple companies, scenario is like this. Switches are in stack. Let's suppose 1, 2, 3, 4. In first stack, there are 4. In stack number 2, there are 3 switches. So if you guys remember in the first class, I told you, one uplink go through this stack and one uplink go through this stack. And this provide the redundancy. Yes, na? If this will fail, it will work. Yes or no, everyone?
Yes.
And not only this, for every stack, there will be a 2 uplink. For every stack, there will be 2 uplink. One is called active and second one is called passive. So when active will goes down, passive will start work. Otherwise, let's suppose if you are using only one. So if this link goes down, or if this uplink goes down, all the 4 switches are not able to communicate. Yes or no? Yes. So to solve this problem, we have how many uplink? 2 uplink in each stack. It provides the redundancy. And these are uplink. It means this is called trunk. So this is the scenario based question, guys. And in real scenario, you guys will face these type of challenges. When you allow any VLAN on this trunk, you must need to allow here also. But in maximum case, multiple engineer is allowing here and here on trunk. And communication is happening, but no problem. But guys, try to understand, if in any scenario, if let's suppose after some days or after 1 month, 2 months, 1 year, this link goes down, you do not have any alternate path. Getting my point? Yes or no?
Yes.
At that time,
Yes.
your manager will ask you what you did. Getting my point? Yes or no? Yes, na?
Yes.
In real scenarios, when you just enable or when you allow the VLAN on this uplink, you must need to allow here. And not only the only one link, you have to allow on active link as well as passive on both. Clear, everyone? I hope you guys understand. Are you tell me?
Yes, sir.
Yes, sir.
Okay. There is here I think we write now where we write that command. This one. Conft interface fast Ethernet 0/1. Switch port trunk allowed. Switch port trunk allowed. And when I write the VLAN, right everyone, when I press this one, you are getting the add word here, guys.
Yes.
Add means what? Add the VLAN to the current list. Right now, let's suppose VLAN number 10, 20, 30 is allowed. Getting my point? Yes or no?
Yes.
Yes. And let's suppose any new project came here and that you allow VLAN number 40 there for that project. So you guys allow now VLAN number 40 here also. Yes or no?
Yes.
So here you guys will add which command? Add VLAN number. Sorry, VLAN 40. Only 40. This is the command. Are you getting my point? Yes or no? Are you tell me? Do
Yes,
so
sir.
interface trunk. See now VLAN number 40 is also.
Added.
So this is the use of add keyword here. Are clear everyone? Tell me here. Clear na?
Yes, sir. Yeah.
Yes, sir.
And all means all the VLAN is allowed. They understand? Yes or no? Understand na? Remove means let's suppose if you want to remove VLAN number 40, if you want to, here I write remove 40, then what will happen? Yeah, VLAN number 40 is now
Removed.
from the current list. Understand everyone? Are tell me.
Or
Clear?
we can write no VLAN 40. This is
No.
second
See, when
option.
you write the no VLAN 40, it means you are just removing the complete VLAN from the switch, na? You are just removing the complete VLAN from the switch. And this is the command too. Not allow the
Trunking.
VLAN number 40 from the trunk link only.
Trunk, yeah, sorry, yeah.
Clear,
You're
na?
right.
Yes. And when you write the all means, guys, all the VLAN is allowed. Yes, na? See, na? All the
Yes.
VLAN is allowed. Very clear, everyone? Yes or no? Understand?
Yes, sir.
Yes.
And there is one more keyword. Na? I think if you see, you guys can explore. There is one more
Accept
keyword.
also
That is
there.
called accept. Right? Accept means, let's suppose on your switch, VLAN number 10, 20, 30, 40, everything is there. And you already write all the VLAN is allowed. But I want all the VLAN is allowed except 40. Tell me right now. Just tell me one thing. So interface trunk. See, all the VLAN is allowed? Yes or no? Yes.
Yes.
So when I write, so VLAN trunk except 40. So what will happen then? Ina, all the VLAN is allowed except 40.
Mhm.
Yes or no? Everyone.
Yes.
Yes.
Yes, na? All the VLAN
One
is
implement.
allowed except 40. Understand? Yes or no?
Yes, sir.
Yes, sir.
Even if you have a one VLAN, you guys can write like this. If you have, let's suppose, except I want to write 40 to 50, then I want VLAN number, let's suppose 100. I do not want these VLANs. So I write like this. Packet tracer is not supporting, but yes, you guys can write like this. In
Mhm.
my point, everyone.
Yes, sir.
Tell me. Clear na?
Clear.
There are multiple things. Packet tracer not support, but yes, multiple VLAN you guys can write like this. Clear, everyone?
Yes, sir.
And none means, guys, no VLAN. You know, na? None means
Mhm.
no VLAN. If I write
We
here,
remove all.
none. None means no VLAN. Is there any VLAN allowed?
No.
No
No.
VLAN is allowed. Clear, na? Everyone? Are tell me.
Yes.
Yes, sir.
Okay. So it means no VLAN is allowed. So if I write so VLAN brief, see na? All the VLAN is there. 1, 10, 30. Every VLAN is there.
Mhm.
Okay. I hope you guys understand something about the trunk. Clear na? Everyone.
Yes, sir.
Yes. Yes, sir.
Okay. Even you guys can change the native VLAN also. What is the command to change the native VLAN, guys? When I write this command, so interface trunk. What is the native VLAN? 1.
One.
What is the command to change the native VLAN? Tell me, everyone.
Interface VLAN 1.
Interface fast Ethernet 0x1. First of all, go on the interface. Then you have to write switch port, trunk,
Mode
then native, then
native.
then VLAN. For example, I want 1001.
Mhm.
Now check. So interface trunk. What is the native VLAN?
101.
What I told you, when you configure the native VLAN on here, you must need to configure on switch number 2 also. In packet tracer, you are not getting the error, but yes, in real scenario or even in the GNS, you guys will get the error. What is the error? Native VLAN mismatch.
Mismatch.
Clear, everyone? Understand?
Yes, sir.
Yes.
So this is the command by which you can change the native VLAN. But in real scenario also, we are not using the VLAN number 1. We are changing the native VLAN. Are you clear now, everyone? Yes or no?
Yes, sir.
Yes.
Yes, sir.
Okay. Anything else, guys? I hope you guys understand something.
Yes.
Okay.